Aloha everyone, welcome back to Hawaii News Now's Extended Stream. I'm Emily Cristobal, and today we have another episode of Repairing Earth. Now, with such a huge need for water catchment tanks here in Hawaii, there's a company that is working to create the process that is both greener and cheaper. They're harnessing the power of the sun, but it's not for electricity. Hope you enjoy the 17th episode of Repairing Earth. Aloha everyone, welcome back to Repairing Earth, and in this episode we are joined by Carl von Kreis, who is the CEO and founder of Light Manufacturing. Thank you so much for having us, Carl.
Hey, it's great to be here. Thanks for having me.
I was hoping you could tell me a little bit about what Light Manufacturing is and what you guys do.
Yeah, thanks for asking. So we're a solar technology company, and specifically what we do that's different is we use mirrors to reflect heat from the sun to the mirror to a target. And by having lots of mirrors reflecting lots of sun onto a target, we can heat things. And so what that lets us do is replace the use of fossil fuels like natural gas or kerosene or what have you with heat from the sun. And we can do a lot of useful industrial processes with that heat without any carbon emissions, greenhouse gases, particulate emissions, you name it. All that bad stuff goes away 100% with the use of that heat. And so while there's a lot of things we're looking at in different sectors, the first thing we decided to create was solar rotational molding. So what's rotational molding? Rotational molding has been around since the 50s. It's the way essentially any large plastic object is made. Think kayaks, water tanks, septic tanks, all those things. And these are really useful, durable products. They're not disposable plastics. They're not your plastic straw. These are things that live for 10, 20 years and serve people for a long time, and themselves are often recyclable. But to make them requires the use of an awful lot of fossil fuels. And what our process does is allow us to make the same products with the same quality, but without needing fossil fuels for heat. And we brought that technology to Hawaii as one of the first commercial deployments, where we're currently operating on the Big Island near Kona and making products for people throughout the archipelago.
Take us, the viewers, to that site on Hawaii Island. What is kind of the terrain? What are we looking at? How is everything set up?
So driving into the Nelha campus, we pass all the way through the campus to the farthest end, right to the west of the Kona airport. We're on the last piece of land of black volcanic rock right beside the blue Hawaiian Oceans. And there, on top of this really rough, unimproved terrain, sits a series of these white shipping containers, or so they appear, with these crazy space-age mirrors circled around one of them. First of all, you notice is you don't hear a lot of noise. You don't smell anything. You don't hear rattling and clanking. You just hear the ocean and the birds and the wind. But as you come around in front, what you'll see is these mirrors, which are beautiful to look at in an array, are focusing all the sunlight on one side of that two-chamber array. And inside of there is a slowly tumbling big thing that looks like a water tank, but it's actually the metal mold that's making the water tank inside. And as that thing slowly turns and tumbles, the heat's on it, you see a few beautiful reflections. And after a while, the heat, the bright solar beam, suddenly moves to the other side of that machine, and it starts moving slowly and creating a new part. On the first side, fans turn on, starts cooling down the molded part you've just made. And after a few minutes, the team comes out, we stop the machine, take off one half of the mold, and out slides a beautiful, perfectly formed water tank, which is ready for sale after a few adjustments. It's kind of magic because you walk out and you feel like at a space launch or something more than in a traditional factory. And it's quite thrilling to see, even for those of us who see it all the time.
Wow, that's super amazing. And I just wanted to understand, how exactly are you able to cut out all these fossil fuels?
Yeah, it's a great question. So if you look at the process, in a lot of industrial processes, what they really want is heat, right? And we're all used to thinking of solar as solar electric. The electric is implied, right? Solar electric. And you think of it as, the panels on the roof of a house. And that's great and incredibly useful. But if you don't need electricity and what you want is heat, you're much better off reflecting all of the heat and light from the sun to a target rather than only converting maybe 20% of it to electricity. If you want electricity, PV is fantastic. But if what you want is as much of the energy as possible as heat, then mirrors, high efficiency mirrors, are the way to go. And what we do is we've created our own heliostat products. These are computer controlled sun tracking mirrors that allow you to keep the reflection of the mirror on a specific target. So you say, I want the heat over there, keep it there even as the sun moves. The mirror makes little adjustments to keep that reflection where you want it. And so you can have a whole bunch of mirrors, like 50 of them, 4x4 or even bigger, and they can put 10,000, 20,000, 100,000 watts of energy onto a target of your choice. And then once you're done using it to heat one thing, you can quickly change the angle of the mirrors and move the light somewhere else. So it's a very flexible heat source to which we combine a computer-controlled molding system to complete a machine that can make water tanks, septic tanks, kayaks, you name it.
That's very cool. Just thinking about that process. And you keep talking about these mirrors. How many mirrors are on your guys' facility out on Big Island?
We have 50 out there of various sizes. Most are 5x5, but now we've implemented a new 4x8 mirror, which is even lower cost, and they're just really huge. So that system, again, we're talking about tens and tens of thousands of watts being able to be delivered instantly to the molding system.
That's very cool. And, talking about, most people think solar and they think electricity, but for you guys are focusing on that heat factor. How hot can the surface of those mirrors get?
Well, the mirrors don't get very hot because they're just, each one of them is only, experiencing one sun, right? The sun hits the mirror, bounces off. So it's actually quite cool. If you were to feel the temperature of the pavement, black pavement, that's very hot. But these mirrors, by their design, are reflecting almost all the heat away and to the target. So the mirrors don't get very hot at all. But the target, which is the mold, this big hollow mold, which opens up and you pour food safe plastic inside of, and then you close the mold, and then it starts turning in two different axes. That surface is painted black with a special thermal resistive paint. And so it gets quite hot, 400, 450 degrees Fahrenheit, which is kind of hot, but it's nothing like the multi-thousand degrees that you would see at some of the California or Nevada power towers where they're making electricity using a lot of these mirrors, which is what most commonly has been done till now with heliostats. Those are extremely high temperature. Ours is actually quite a relatively safe and low temperature process. So we're not burning the plastic or emitting any fumes. We're literally just heating it up to the point where it melts and sticks together to form that nice thick wall for your water tank or your other product.
Wow, thank you so much for explaining all of that. And I was just curious, how does this process compare to the usual process of making these products?
It's been an interesting thing because our goal here is to improve the sustainability of rotational molding because rotational molding is how you make these big objects, right? So some of our products are, 300, 500, and 1,000-gallon water tanks for rain catchment. Those are our primary things. As you know, there's a lot of rain catchment for communities on the Big Island. And so, and the challenge traditionally has been that rotomolded products like tanks are big. And they're also mostly air, right? There's the skin on the outside and there's a lot of empty space inside. So they're very expensive to import from the mainland. And if you're going to make them on island, then you have to import your fossil fuel heat, which is both expensive and polluting. So what's an interesting contrast is we can make very high quality tanks for typically 30% less than the traditional sources. And that's a huge difference if you're talking about something that's essential to people's lives. And by making them locally, we're employing on island. We are improving Hawaii's resiliency and again, expanding the access to people to catchment tanks and other products because they are more affordable.
How long does the process take?
Yeah, it's a great question. So the process there's the heating cycle and the cooling cycle. And once we're done heating one product, meaning we've made one tank on one side of we have a 2-chamber molding system. So on one side, we'll heat that tank up or that mold and melt all the plastic, get it sufficiently hot. And our computerized system knows when it's hot enough to be a good product. And then automatically we'll switch from that side to a mold on the other side. So it's a continuous back and forth as it heats one side, then it heats the other side, and then this one's cooling, this one's then cooling, this one's being extracted, and so forth. the heating process takes 45 minutes to an hour, depending on the tank size. So, which is about the same as what it is for a traditional molder, which is interesting.
That's super cool. And, goes to show that through this process where you're able to, not have any emissions, not have all this electricity being used, but you're able to have the same output, which is
Yeah,
awesome.
yeah. When we started the project, several years ago, our goal was really to prove that it wouldn't work because the assumption was this must have been something that has been tried already. I mean, come on, it's a heat intensive process. Someone must have tried it, and it turned out actually it hadn't been tried. So we scaled up, working initially with some really small products, all the way up to now our largest product is 1,000-gallon water tank that stands 6 feet high. And we have bigger machines in production to make bigger things down the road. And so we're very excited about that. An interesting point is the factories themselves, they're not factories like anyone thinks of them. These are modified shipping containers that pack up for transport, are dropped on a bare piece of ground. We don't even dig holes for anything. There's no concrete poured. It's literally just resting on the ground. We deploy the PV panels on the roof to run the motors and things, and we deploy the heliostats out, in front of this, 50 or more of them. And within a week or two, we can have a factory set up and producing useful product in something that just looks like a traditional molder's extra storage space. So what a factory has become a lot smaller and a lot more flexible because of our lack of need to tie it to the grid, to pour concrete foundations, to put up big buildings. None of that's required for our process.
That goes to show it's like if a community needs it, like you could easily replicate this whole process and bring it to a community that's closer versus than like shipping everything. You really just show that you really can just have this in multiple places to meet the need of the community.
Our goal generally is in the same way that back in the dawn of computers becoming popular, there were the mainframes and they were at big universities and research centers. And then people had, the first PCs, which were thought of as just toys for hobbyists. If you want real computing work done, you go to the big machine, and the little machines, for kids or what have you. But it turned out, of course, as we know now, that small deployable computers are how it works, right? That's how we live now. And we think in certain applications, many distributed factories like ours, close to communities, can easily outcompete the big centralized factories because of the problem of transporting these big, bulky products to market. So in that way, Hawaii has been a great lab for us in proving that concept.
I had a question of how you guys actually started to come up with this idea and why you guys started.
The initial impetus was I worked in for a super high quality flight case manufacturer, making stuff to put satellite parts in and all kinds of high tech gear. And their company's products were all rotationally molded and then added engineering features to them. And looking at the way the process worked, it just struck me seeing it in person. And it's a cool process to look at, but you feel like, gosh, we're spending all this money on these gigantic gas burners to heat this big metal mold that's twirling around in this kind of, hot, intense environment. And the second you got that thing hot enough, what do? You turn off the burner, you start spraying it with water, you turn on big fans, and eventually you get the finished part out. Now that's fine, but it just felt really weird to watch us spending all this money on natural gas that then was essentially making the thing hot and then throwing all that heat away immediately by cooling it down again. You thought it just felt wasteful. And so that stuck with me for a long time. And then I got an opportunity here in California to build an experimental version of this. And again, as we thought, it was probably not work out. That was built to fail. And then it failed to fail, and we kept going with this. And once we realized the fact that these factories could be small and could be deployable and could be close to markets, then we thought, wow, that is really changing the economic game. I bet we can make stuff cheaper, better, closer, greener. And that's what we're doing right now.
Yes, and your facility right now is on Hawaii Island. Why did you guys choose Hawaii Island to have this facility be made?
Two reasons, several. One is the need for catchment, the fact that water tanks are not just a sometimes thing, but the fact that such a high percentage of Hawaii Island has the need for catchment, we felt we could make a big impact there, and it was a good environment for us to compete in. So, solar conditions are quite good on the west side, and we are tenants of the Nelha Research Park, which is a great facility that's providing land access for us and infrastructure, and along with the many other cool projects I should say they do there around aquaculture and different industries. It was a natural place for us to be, and they've been a great host for us.
And, I really just wanted to kind of hit home as to what this rotational molding can be used for. Like, what products do we see in our daily lives besides like these water catchment and other things that people are using? They can kind of visualize, yeah, this is things that could be built in a way that's carbon free.
Right. And that's a great question because we started knowing that, having done market research, we knew we could supply a need for lower cost catchment tanks. We're very interested in looking at septic tanks because, as you know, there's a lot of need to replace cesspits, cesspools with septic systems, and we may be able to be part of that solution at a lower cost. You see things like sit-on-top kayaks. That's a rotomolded product. A lot of water sports stuff is done that way. Furniture, handling containers. Like you'll see a big plastic dumpster used to roll around and transport cardboard or something. That's often rotomolded. If you see the kind of like covers that protect posts in the ground, that's called bollards. Those are rotomolded. A lot of electrical cabinetry and components, pipes. A lot of large pipes are rotomolded. The kind that get installed in the ground as part of water management systems. So there's a whole host of things. If you look at something and it's big and it's plastic, it's very likely rotomolded. And in general, we're interested in hearing from folks that could be in the ag sector, government, fisheries, you name it. If you've got substantial need for, meaning several hundred plus of something that's a large plastic object and you're importing it now, we should talk because we may be able to do it for you in a way that's greener, cleaner, and more affordable.
How many, like number wise, do you guys produce each day?
It depends on sun conditions, of course. I think our peak at this current site has been 7 tanks a day. And we've seen, and there's some days where if you've got a lot of VOG or other issues, then, it's 0. So it's a little bit of a prediction game. But we've seen 7 be a high number for us so far, and that was a pretty great day.
I was looking around your website and you guys have a lot of cool different projects besides this main like rotational molding. One thing that really piqued my interest was the plastic shredders. And I was hoping you could explain what exactly that is.
For water tanks, you have to use new virgin plastic for safety. You don't always know what's in a post-consumer waste stream. Maybe it's an oil container or something used for medicine. So you have to be cautious. So with water tanks, we always use 100% FDA compliant food safe plastics, and which, by the way, themselves are recyclable. Like a great thing about a big, heavy plastic object is it's easy to go grab that thing and cut it up and reuse it because the plastic's concentrated into the one large object. One of the problems with things like plastic straws or small toys or what have you is that they're very hard to catch once they're out in the environment. And so the cost of getting them is very high. But going back to the shredding idea, one of our goals is for more remote communities that don't have the ability to truck large amounts of post-consumer plastic to a big, typically mainland recycling facility. We wanted to see if we could bring that technology to the islands and to similar communities. And so first step is to have solar-powered shredding systems that can take one of our products at end of life, someone else's water tank at end of life, a kayak, and after initially cutting it up, shred that into smaller component pieces of plastic and allow us to make something new. Again, not probably a water tank, but a planter or other useful thing. So that's the midterm goal, is to be doing post-consumer shredding of big rotomolded objects. And ultimately, we have goals to be able to incorporate post-consumer waste like milk bottles, shampoo bottles, things like that for use in other products. But that's down the road, probably 6 months to a year.
Yeah, that's awesome. And the reason why I bring it up is because a lot of people think of, recycling, the plastics that we use all the time. You mentioned it, shampoo bottles, toothpaste containers, toothbrushes. everything has so much plastic in it nowadays. And, you know, thinking about recycling too, like everything that's recycled can't always be, actually recycled into something new. And that's why it really piqued my interest of being able to one day, you guys are still working on it, but, be able to use those plastics and use it in new ways rather than have it, wash up on our shores and the ocean and affecting all that native life and all of that.
Exactly. And I think you have to treat this as a best fit for the job and doing things in stages. So, ultimately, if you didn't have to dig up any aluminum ore or extract any fossil fuels to make anything, that's optimal, but very hard to get there, right? And so for me, you have to pick your shots of what's the best use of a material for an application. I mean, aluminum is a great material, but it's tricky, especially when you're first extracting it, has a lot of energy inputs and is quite disruptive. Very recyclable after that. Glass has an environmental footprint. Wood has an environmental footprint. So I think plastic has its own unique challenges and problems, as we all know. And what we like about what we're doing is we're using these food grade plastics in their best possible application, which is long lasting, durable, and really critical to human quality of life, right? If you're talking about septic tanks, for example, or water tanks, these are not nice to have things. These are really have to have things. And if you can mold those sustainably, eliminating the fossil fuel from the molding process, then I think you're really stepping up something that without our technology is, again, stuck being a highly pollutive process that goes back 50 years and really hasn't improved in all that time. It's really rare in the clean tech or green space that the better solution, the cleaner solution, the sustainable solution costs less, right? We're so used to paying a little more or even a lot more to get the sustainable product, right? Be it organic or, insert your metric of choice. And, a lot of us do. If you can afford it, it's a nice thing to be able to do. But in this case, with this technology, we're actually able to bring products of the same or even better quality to market for 30% less. So it's a competitive advantage, but it's also nice to sort of remove the green tax from an important spend. Something that's costing a decent bit of money is now costing you, 30% less. That's pretty unheard of for a sustainable product. And that's part of what makes this so fun to bring to a market.
Yes, I'm so glad you brought that up because you guys are really serving the needs of the people of Hawaii and really bringing that to them versus having to ship them. And that's just so important because you're not just making more plastic to make plastic things, you're making them to help the community, to help the people that live here. And like you said, it is a need. It's how to survive.
And I'd also say we've been pleasantly surprised by how much interest there have been from off of the Big Island, meaning we've shipped to throughout the archipelago with Young Brothers. It's been fair, we've learned how to do that. So if folks listening are thinking, well, I'm on Oahu or Maui and I want these products, I guess I can't get them. Actually, you can. And we've fulfilled orders to many of the islands now. So reach out. It's on our website and we can arrange logistics and get you tanks wherever you might happen to be.
Just thinking about the future of this technology, how else do you think it could be used?
We have a lot of plans, some of which I can't talk about. But I and my team, we feel that there are a host of applications for the real-time use of solar thermal energy to replace fossil fuels in industry. The key question for us is which ones are most accessible most quickly? Where can we do the most good the most quickly? I will say that the field recycling of post-consumer plastics is very interesting to us, but there are several other industries, some of which are in the Hawaiian archipelago that we're interested in, which we just can't talk about yet. So stay tuned.
Yeah, no worries. This is definitely a company to keep an eye out for to see the very interesting things that you guys are working on. And thank you so much, Carl. Is there anything else that you'd like to add or what you wanted to share?
If folks want to see pictures of the process, check out pricing, look at our frequently asked questions, send us a message, or place an order online. We've set up our special website just for Hawaii, which is hawaiitanks.com.
For more stories like these, or for more episodes of Repairing Earth, head to hawaiinewsnow.com or Listen wherever you get your podcasts. This is your host, Emily Cristobal, and mahalo for listening.